Morning class. Morning class. So today we'll be having physics. We'll be doing physics today, and the topic will be current electricity. So we'll be doing physics. The topic is current electricity. So what's current electricity? Current electricity is current electricity is kind of the same thing as electric current. So when you're talking about electric current, how do you define electric current? It's simply the flow of charges in an electric circuit. So electric current is simply how charges flow in an electric current. So you can say flow of charges in circuit. That's add electric, so flow of electric charges in a circuit. So we can also say is the flow of electrons. I say it's the flow of electrons because electricity is caused by flow of electrons. So you can also say it's the flow of electrons through a circuit. So that's electric current. So now electric current is when you're talking about electric current is, in physics we always work with the notions and then units and all of that. So electric current is denoted with I. Electric current is denoted with I. So where you see I, capital letter I, that's I in uppercase like this, it means electric current. So electric current is denoted by I, and it is measured in ampere, which is ampere, and ampere is represented in this way, capital letter A. So when you're talking about electric current, when you see an uppercase I like this, this is electric current, and then it is measured in ampere. That's ampere is the unit of electric current. So, and as UTME students, you're working with keynotes, so you should be able to understand these keynotes like that. So when you're talking about electric current, you should know flow of charges in a circuit, and it is represented with an uppercase I, and then its unit is ampere. Okay, so when you're talking about current electricity, everybody knows we're talking about resistance, potential difference. Potential difference is what most of us call voltage. That's potential difference, current, and all of that. So I've done electric current, which I said is the flow of charges in the circuit. I'm also saying it is represented with uppercase I, and then its unit is ampere. So now let's move to resistance. What's resistance? From the word resistance, resistance simply opposes the flow of charges in a circuit. Resistance is the opposing of flow of current in a circuit. Now, why do I have to oppose the flow of electric charges? Because from electric current to take place, there have to be flow of charges. So why do I have to oppose it? Now, the reason for opposing the flow of charges is to be able to control the amount of current that is passing through the circuit. Now, take for example, maybe let me say you're trying to organize a wedding or something like that, and then you want to take in 100, I call them 100 guests. So how are you going to do it? You're going to you're going to print 100 invitation cards, and then after printing the invitation card, for you to make sure your guests are not more than 100, what are you going to do? You're going to put the security at the door or at the entrance. So that security you're putting is like a resistance to be able to contain this number of guests that you plan to have, that you plan for. So what it means is in a circuit or in an electrical appliance, there's always a particular amount of current that appliance can take. So now if you are bringing in a current that is higher than that, the work of the resistance is to control the current coming in. So after controlling it, it regulates the flow and opposes the other one, takes in what is needed, and then the remaining ones opposes it. So resistance is simply opposing of flow of electric current in a circuit. So the opposing of flow of electric current. Now resistance is represented with uppercase R this way. Resistance represented with uppercase R, and then it is measured in ohms. That's its unit is ohms. Ohms this way, and it's spelled. So the unit of resistance is ohms. It is represented with uppercase R, and then its unit is ohms. Now, when you measure, there's a device for measuring resistance. Now, to measure the resistance of a particular device, you use something called ohm meter. Ohm meter is used for measuring resistance of the resistance in a circuit or resistance of an appliance. So when you have the ohm meter, you need to measure your resistance. Now, I said resistance is the opposing of flow of charges in a circuit, or the opposing of flow of electric current, or the opposing of electric current in a circuit. So that's resistance. It is measured in ohms. Remember, we working with keywords. It is measured in ohms, and then it is represented with an uppercase R this way. Now, the next thing is potential difference. What's potential difference? Potential difference. Now, when you're talking about difference, you should mean two things. When you're talking about difference, then you definitely should have two things. So, potential difference is like you are finding the amount of energy that is taking a unit charge to move from one point to another. Like, for example, I have a point here, I'll name it A on my electric, on my circuit, and I have another point B on my circuit. Now, the potential difference between these 2 points A and B is the amount of energy taken by one unit charge. When I mean one unit charge, I mean one coulomb. You should know that the quantity of charge is in coulombs. So now, when I mean one unit charge, I mean one coulombs. So the amount of energy taken by one coulomb to move from A to B is the potential difference of these 2 points. Now, when I say potential difference is represented by V and then the 2 points. That's for here, for my example here, my 2 points are A and B. So I'll say potential difference AB is the amount of energy required for one unit charge. That's for one coulomb of a charge to move from point A to point B. Or you can say it other way, to move from point B to point A. So that's your potential difference. Don't forget, potential difference is represented with V, and you can add this. That's if necessary. In the question, maybe they give you the potential difference between 2 points A and B, or X and Y, or point A and point F, or something. You can write it like this. Or if they don't give you, they just tell you the potential difference. You can just write it as plain B like this in the upper case. Don't forget in upper case. Now, the total amount of energy to take one unit charge or a unit charge of electricity to move from one point to another in the electric circuit is my potential difference. Now, potential difference, some people call it voltage. So it is measured in volts. Potential difference is measured in volts, like this, volts, and it is represented by capital letter V. So when you calculate and then you want to write your answer, maybe probably your answer is 5, you write 5 volts. So V is giving it units. That this unit is to make this quantity, for it to add value to this quantity you are giving it. So after solving for your potential difference, you write 5 volts for your current, and for your resistance, you do the same thing, always adding units at the end of it. When you are not adding units, then definitely you're wrong. So you add units. Yeah, that's when you're working with calculation questions. Now, talk about resistance, current, and potential difference. So there is in an electric charge, there should be resistance is R, potential difference is V, and electric current is I. So now there is a relationship between these three quantities. What is the relationship between these three quantities? Now there's something called Ohm's law. Yes, Ohm's law this way. So now this Ohm's law shows us the relationship between these three quantities. Now, what is Ohm's law? Ohm's law, okay, let me just state it. Ohm's law states that the current, the voltage of an electric current is directly proportional to the current, provided temperature and all that quantities remains constant. So now, the voltage of an electric current, this is it. I think we all know variation. So the voltage of an electric circuit is directly proportional to the current. That's directly proportional to current, provided that the temperature and all other physical properties remains constant. So now, when all other properties like temperature, pressure, and all of that they are constant, then the voltage is directly proportional to the current. So now, from here, this will become V is equal to Ki. You should know that this K is called constant of proportionality. Now, in Ohm's law explains to us that this constant of proportionality is my R, which is resistance. So if I replace this K with R, I can say my V here is equal to Instead of writing K, I'm writing R is equals to R I. So definitely this is not sounding well because R is, comes after I on my alphabetical whatever. So I can write B equals to IR. So here I have the relationship between potential difference, current, and resistance. Now, don't forget my V is my potential difference, I is my electric current, and R is my resistance. So now, here is the relationship between resistance, potential difference, and current. So that's what Ohm's law explains. Okay, let me come over again. Ohm's law states that the voltage of an electric current is the voltage of an electric circuit is directly proportional to its electric current, provided temperature and all other physical properties remains constant. So that's what we represented here on stuff. So you have this formula at the back of your mind, V equals to IR. V is your potential difference, I is um your I is your electric current, and R is your resistance. Okay, so let's take a question. So this question, so for example, I want to find the potential difference in an electric circuit is 5 ohms. The potential difference of an electric circuit is 5 ohms. It's 5 volts, sorry, 5 volts. Potential difference in an electric circuit is 5 volts. And then the resistance is 2 ohms. My potential difference is 5 volts. And then my resistance equals to 2 ohms. Find the electric current. So to find electric current, you can say find the current passing through passing through a circuit with potential difference of 5 volts and a resistance of 2 volts. So what am I going to do? I'm going to impute my values into this formula. What's my formula? My formula is V is equals to I R. So now here, what's my V? My V is my potential difference, right? Potential difference is 5 volts. And then my I is electric current, which does not have a value. I don't know if that's what I'm looking for in the question. And then my R is 2 ohms. So what I'm going to do is I'm going to replace these values into my formula here, V equals to IR. So what's my V? My V is 5 volts. It's equals to I times R. What's my R? My R is 2. So this becomes 5 equals to I times 2. And now 5 is equals to 2 I. Now from here, for me to get the value of my I, which is electric current, I'll divide through by 2, isn't it? So when I divide through by 2, I'll have I is equals to 5 divided by 2 will give me 2.5. And then here is my answer. But then I'm not done. This is not correct if I leave my answer like this. So I have to put my unit. I is equals to 2.5 ampere. So this way I have my answer as 2.5, which means the amount of electricity passing, the current passing through a circuit with potential difference of 5 volts and a resistance of 2 ohms is 2.5 ampere. Okay, let's take another question. You can say find the potential difference. Find the potential difference of an electric circuit with current of 0.2 ampere, current of 0.2 ampere, and a resistance of 5 ohms. Electric current of 0.2 ampere and then resistance of 5 ohms. So I want to find the potential difference of this circuit. So using my same formula, V equals to IR, I will have my V is my potential difference. I don't know it's right. V is equals to, so my electric current is 0.2 and my resistance is 5. So this becomes 0.2 times 5. So what am I going to have? I'm going to have V is equals to 1 volt. So if I multiply 0.2 times 5, I'm going to have 1. So the value of my potential difference is 1 volt. Okay, so those are, now we've explained current, That's electric current, resistance, and then potential difference. Ohm's law. So Ohm's law is the law that brings the relationship between these two quantities together. So now let's move to EMF of itself. What is EMF? EMF is electromotive force, right? So we know EMF. When I say EMF, EMF. So EMF is electromotive force. So that's what EMF is. So when you see something like EMF, what does it mean? Okay, so EMF of a cell is the potential difference between the cell, the potential difference between two terminals in the cell when it is not connected. So EMF is simply the potential difference between the cell when it's not connected, or you can say it's the maximum energy or maximum force that the cell is going to have at a particular time. So the potential difference between two cells when it's not connected, that's the electromotive force. So electromotive force, which is EMF, is represented by uppercase E this way. Uppercase E represents this with uppercase E. And then it is also measured in volts. It's also measured in volts because EMF is potential difference. The potential difference, that's the maximum. You can also call it the maximum potential difference between 2 points or two terminals in a cell when it's not connected. So EMF is also measured in volts because it's kind of a potential difference between the force. So EMF of the cell is represented with an uppercase E this way, and then it's measured in volts. So now we have this as my EMF. So um just like the potential difference that is measured E equals to IR, my electromotive force is also E, that's uppercase E, which is electromotive force, is equals to IR, where my I is current, electric current, and R is resistance. So I have E equals IR as my electromotive force. So now we're going to move to calculations, but not yet. Before we move to calculations, let's do with internal resistance. Internal resistance. What is internal resistance? Internal resistance is like the resistance that is built in the appliance itself, like the resistance of the circuit itself. When I'm talking about internal, something that is within the circuit. So, resistance is the opposing of flow of charges, right? So, internal resistance is simply the opposing of flow of charges presented by the circuit itself. So the circuit itself has an internal resistance. Okay, now like the example I used, probably after taking in your 100 guests from your wedding by putting the security outside, and probably you want to create a peaceful environment in your wedding room. You don't want someone to create nonsense in the venue of the wedding. From this 100 guests, then you can put in maybe like a bouncers inside the hall when the wedding is taking place. So that's like an internal resistance. So internal resistance is just the opposing of flow of charges by the cell itself or by the circuit itself. So the resistance is coming from the circuit itself. And then internal resistance is represented by lowercase r this way, smaller r this way, lowercase r, internal resistance. So when you're talking about internal resistance, you just have lowercase r, and because it is resistance, definitely it's measured in ohms. So internal resistance is also measured in ohms. That's this way. So don't forget it is the inherent, you can say inherent or self resistance coming from the circuit itself. So that's internal resistance. So now to bring the relationship between electromotive force and internal resistance. Now, I said electromotive force is the maximum potential difference between 2 points or two terminals in your circuit. So now I have E is equals to IR. Now E is my electromotive force. From here, I said electromotive force is equals to IR. So my E is what? My electromotive force. My R is my electric current, and R is resistance. So now I want to bring the relationship between R, that's small letter R, which is my internal resistance, and then electromotive force. Now, for me to be able to get the total maximum electromotive force in itself, I have to calculate the potential difference of the external circuit and the potential difference posed by the internal circuit. That's this uppercase R is coming from an external resistor. External is the external resistance of the cell. Why this is internal resistance, small letter r. So for me to get the value, don't forget we say V is equals to IR. So which means V equals to IR. I can replace this IR with V and I can see so why is because I have not gotten the potential difference coming from the internal circuit of that cell. So how do I get the potential difference? Potential difference is V equals to IR, right? So my R here is small letter r. So what I'll do is I'll add up the potential difference of the internal circuit plus the potential difference of the external circuit. And then the potential difference of the external circuit is this capital letter V. Don't forget potential difference is the product of my electric current and my resistance. And what is my internal resistance? My internal resistance is small letter r. So which means to get the potential difference of the internal circuit, I'll multiply the current times the internal resistance. So my current times internal resistance will be current, which is I, times my multiplied by my internal resistance, which is small letter r. And I'll have r is with small letter r. So the relationship between the EMF of a cell, which is electromotive force, and then internal resistance is this formula. That's the total EMF of a cell. Okay, the total EMF of the cell, which is E, you can say E total, is equals to the potential difference of the external circuit, which is capital letter V, plus the potential difference of the internal circuit, which is I times R, right? And I is my electric current, and this is my internal resistance. So I have EMF total. Now don't forget I said V is equals to IR. That's V equals to IR. So instead of writing this V, I can replace this with IR. So I can say IR plus IR. Now this is small letter. This is external resistance and this is internal resistance. So I have my E is equals to the potential difference of the external circuit plus the potential difference of the internal circuit. Now here, something is common. That's my I, which is electric current. So I can say E is equals to I open bracket R plus R. So here I have the EMF of my cell is equals to electric current, then open bracket, the value of my resistance, that's external resistance plus internal resistance, that's the value of my EMF. So I have this as the relationship between the EMF of the cell and the internal resistance. So let's take examples. So let's take an example. Saying cell effective in cell, sorry, in a circuit, a cell with an EMF in a cell, in a circuit, in a circuit, a cell with an EMF of 1.8 volts and an internal resistance, that's internal resistance, small letter R, of 0.2 ohms is connected to a resistor. It's connected to a resistor with a resistance of 55 ohms. Now, let me go through the question again. In a circuit, a cell with an EMF of 1.8 volts, I've written this, that's the EMF of the cell is 1.8 volts, and an internal resistance of 0.2 ohms is connected to a resistor. So it's connected to the resistor. So that resistor is connected to, we will have an external resistance, that's capital letter R, of 55 ohms. It's connected to a resistor of 55 ohms. Find the or calculate the current flowing through the circuit. So now the EMF of my cell is 1.8 volts. The internal resistance of the cell is 0.2 ohms. And then it is connected to a resistor of resistance 55 ohms. Now I'm to find the current passing through the cell, the current passing through the circuit. Now, from my formula, I have electromotive force is equals to electromotive force is equals to my current open bracket R plus R. So now here I'm looking for my electric current. My electromotive force here, what I'm just going to do is I'm going to replace all these values inside my formula here. So my electromotive force here is 1.8 volts. My electric current is unknown, I don't know it, so I write it as I. And then my resistance, that's external resistance, copper case R, is 55, plus my internal resistance, 0.2. So I'll add this up, I'll have 1.8 is equals to I. When I add this 55 plus 0.2, I'll have 55.2. So for me to get the value of my I, okay, for that, this is the same as 1.8 is equals to I times 55.2. So for me to get the value of my I, definitely I'm going to divide through by 55.2. So I'll divide by 55.2. I'll divide this by 55.2. So I'll need my calculator for that. This is definitely going to cancel out this. So I have my I, which is my electric current, to be 1.8 divided by 55.2. Now I have 0.032. So I can just leave it to two decimal places like this. So my value of my electric current is 0.03. So now, if you've not added unit, the answer is not correct. So you have to add ampere, which is A. So the value of my electric current, which is passing through this cell of EMF, 1.8 volts, and then an internal resistance of 0.2 ohms, and then connected to an external resistance of 5 ohms is 0.03 amperes, which is my electric current. Okay, let's take another question. I think we have like 10 minutes more. Okay, a cell with an EMF of 2.5 volts. Cell with an EMF of 2.5 volts. So the cell has an EMF of 2.5 volts. And an internal resistance of 0.3 ohms. It's connected to an external resistor. External resistor of resistance 44 ohms. External resistance external resistor of resistance 44 ohms. Calculate the voltage. So I have to find the voltage. Now here is I have my electromotive force to external resistance to be 44 ohms. Now the question is saying find the voltage across the external circuit. Now the first question asks us to find the current passing through. That's the first example. Asks us to find the current passing through the circuit. Why this is asking us to find the voltage of the internal resistance. So now don't forget my voltage is equals to V equals to IR. That's my potential difference of what you call voltage. Is V is equals to IR. So I have the value of my R, but I don't have the value of my I, which is electric current. So the first thing I have to do here is I have to find my electric current first. So when I get the value of my electric current, then I can input it here to get the value of my voltage. So to get my electric current, I have E, which is electromotive force, equals to I, open bracket, R plus R. And then you just substitute these values into this formula. So I have 2.5, which is my electromotive force, is equals to I. My R is 44 ohms, that's external resistance, plus my internal resistance, which is 3.3. So this will give me 2.5 is equals to I, then 44 plus 0.3, so to give me 44.3. And then this will be 2.5 is equals to I times 44.3. So here, what I'm going to do is I'm going to divide through by 44. So I move to my calculator and then divide through by 44.3. So I'm dividing this by 44.3. I've left with I is equals to 2.5 by divided by 44.3. So it's going to give me 0.056. And if I want to leave this in two decimal places to become I is equal to 0.06. And don't forget you add your unit, which is ampere. So now I've gotten the value of my electric current. But then the question asks us to find the voltage of the external circuit. So what I'm going to find is I'm using this to, this is not my final answer. So my final answer, the final answer to get the question is to find the voltage. So what I'm going to do is I'm going to replace this, which is my electric current, in this. So my V equals to IR. Don't forget I have the value of my R as 44. So this will become V is equals to my I that I just calculated is 0.06, 0.06 times 44. So, and then my voltage is going to give me, when I multiply this, I have 2.64. So this is the voltage of the external circuit, and I add my unit, which is volts. So you have the answer to your question here. You just have to understand all these formulas and then be able to interpret the question. After interpreting the question, take each values of the quantities and put it in the formula. So yes, I have another question. Okay, so let me just go through what we've done. We did current, which I said is the electric current, which I said is the flow of charges in an electric circuit. Electric current is the flow of charges in an electric circuit. I also said potential difference. Potential difference is the energy required for one unit charge to move from one point on the circuit to another point on the circuit. The energy or total energy required to move one unit charge of electricity from one point on your circuit to the other point. Y resistance is simply the opposing of flow of electric charges. And I said Ohm's law, which is the relationship between these three quantities is the proportionality of my current to my potential difference of voltage when temperature and all other constants and all other physical properties remain constant. So I also said EMF of the cell, which is the maximum potential energy between two cells on your circuit. The maximum potential energy between two cells on your circuit. So when I have internal resistance, which is the resistance coming from the circuit itself, that's just from the word internal, coming from the resistance itself. So with this covered like part A in electric in current electricity. So you can go through this and then keep the key points. We work with the formula. We have formula P equals to IR, and then we also work on another formula E equals to I and R plus R. So this was derived from Ohm's law. Why this? I got this with imputing the value of my voltage or potential difference into this EMF, which gave me the sum of my external, the potential difference of the external circuit plus the potential difference of the internal circuit, which gave me my electromotive force. So with these formulas, so I think I'll see you guys in the next class. If you have any question, have a nice day. Bye. See you.